We create just an insane amount of digital information every single second. But have you ever really stopped to think about how long any of it will actually last? A photo, a document, a piece of research? How much of that is going to survive 100 years, let alone 1,000? Well, today we're diving into a technology that aims to make our data last, well, pretty much forever.
Oh, yeah, we've all been there. That jolt of pure panic as the screen just freezes, filled with code you can't possibly understand. Your computer just stops.
Or maybe you get this one, the dreaded kernel panic. It is literally the digital equivalent of a heart attack for your computer. And it all leads to that same awful, sinking feeling. That final, horrifying realization that your work, your photos, your memories, they might just be gone for good. But what if that feeling could just become a thing of the past? I mean, what if we could actually create a way to store our most valuable information forever? Well, that brings us to what's been nicknamed the Superman memory crystal. And yeah, that is exactly what it sounds like. A direct nod to the memory crystals from the classic 1978 movie. It's a technology that promises to make our data practically immortal. And look, this is not science fiction. We're not making this up. As far back as 2016, researchers at the University of Southampton announced this massive breakthrough in data storage, so profound it could preserve our information for literally billions of years. Okay, so let's get into the numbers, because honestly, they are just staggering. First up, capacity. A single one of these glass discs, about the size of a CD, can hold 500 terabytes of data. To put that into perspective for you, that is 10,000 times the amount of data on a standard Blu-ray disc. I mean, just try to picture that for a second, replacing a huge tower of discs with a single piece of glass in the palm of your hand. And then there's the number that just completely breaks your brain. Longevity. The data on this glass is estimated to survive for 13.8 billion years. That's, well, for all intents and purposes, that's the entire age of our universe. And it is unbelievably tough. This storage medium can survive temperatures of up to 1,000 degrees Celsius and stay perfectly stable. So this isn't just about cramming a lot of data in one place, it's about building a real, honest-to-goodness time capsule. So how in the world is this even possible? How do you write data that can outlast entire civilizations? Well, the answer lies in a really clever combination of light and glass. Okay, so the official name is 5D optical storage. It uses something called a femtosecond laser, which you can think of it like a camera flash that's so incredibly fast, it can interact with stuff on a molecular level without just, burning it to a crisp. It uses that laser to etch these tiny self-assembling nanostructures inside fused quartz glass. All right, so let's break down where that whole 5D thing comes from. The first three dimensions, super simple. It's just the physical location of the data point. Your classic X, Y, and Z. Up, down, left, right, forward, back. But the real magic, the secret sauce, is in dimensions 4 and 5. Now, these aren't about location, they're about the properties of the nanostructure itself, its size and its orientation. These two extra properties change the way light passes through it, allowing each tiny little point to hold way more information. It's this multi-layered approach that allows for such incredible data density. Okay, so it sounds absolutely perfect, right? A nearly indestructible library of all human knowledge. But for years, this incredible tech had one major, crippling flaw. Here was the catch. Writing the data was just painfully, unbelievably slow. The process of etching these nanostructures took so long that it made the technology totally impractical for almost any real-world purpose. It was a brilliant idea that you just couldn't actually use efficiently. But hey, the story doesn't end there. Of course not. The researchers at Southampton just kept working at it, determined to get over this one massive hurdle. And eventually, they found a completely new way to write the data. So here's the new method they cooked up. First, they used a high-rate laser, but instead of one big, powerful blast, they used a series of weak, rapid-fire pulses. This kicks off something they called near-field enhancement, which very gently creates these tiny data voids without causing any heat damage. The result is a process that's both much faster and way safer for the disk itself. So, what was the result? They were able to hit a writing speed of about 230 kilobytes per second. Now, I know what you're thinking. That doesn't sound super fast compared to your home internet, right? But believe me, in the world of 5D storage, this was a massive leap forward. But let's be really clear about what that speed actually means in practice. To fill just one 500 terabyte disk would still take about 2 months of nonstop writing. This really tells you that the technology, at least for now, isn't meant for your everyday photos and documents. Its true calling is archiving, creating a permanent, unchangeable record of our most important information. So, with the speed problem now more or less manageable for archiving, we have to ask a much bigger question. I mean, what does it actually mean to have data that can last forever? What are the real-world implications here? Well, the potential for good it's almost limitless. I mean, think about it. Unlike what we use now, magnetic tape, hard drives, that can degrade in just a few decades, this is truly permanent. We could save everything from the Magna Carta to crucial medical research, ensuring it all survives any future cataclysm. This technology could create a library for humanity that truly stands the test of time. But, with any powerful technology, there's always another side to the story. If you can store that much information that securely, what happens if it falls into the wrong hands? Analyst Rob Enderle put this risk into really sharp focus with this quote. The very same permanence that makes this technology perfect for preservation also makes it a terrifying tool for data theft on an unimaginable scale. So, as we're standing right on the verge of creating data that can literally outlast humanity, we're left with this profound question. How do we make sure it preserves the best of us and not our worst secrets?